There are three states of matter: solid, liquid, gas. Solid. The particles in a solid are closely packed together. They vibrate but cannot move around. Solids keep their own shape. Liquid. The particles in the liquid are less closely packed together and move around. Liquids can change their shape. They often take the shape of the container they are put in. Gas. The particles in a gas can move around freely in all directions. Gases can change their shape and spread out. Heating and cooling can make materials change from one state to another. Heating can change a solid into a liquid. Melting. 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 Heating can change a liquid into a gas. Evaporating. Cooling can change a liquid into a solid. Oh, freezing. Cooling can change a gas into a liquid. Condensing. Solids melt into liquids. Liquids evaporate into gases. Liquids freeze into solids. Gases condense into liquids.
Alright everyone, I hope you enjoyed that little preview video. Okay, now we're going to continue our lesson about material changes, the state changes to be exact. And in this lesson, the video was a recap of what we have learned previous lesson about changing states of matters using heat, okay, and cooling down, and those were all the processes that it goes through. Okay, so now we have something called irreversible change. So what is an irreversible change? So let's see. Okay, now we have heating, mixing, burning, rusting, and all of these processes really change the states of matter. Okay, an irreversible change is where the material cannot be returned to its original form. Now, as you have seen in the video, um, chocolate can melt into, can melt and turn liquid chocolate, but then you can just cool it off and leave it at room temperature. It goes back to being solid. The shape will change, but basically it will go back to solid. So that's a reversible change. That the matter can change back to its original form before it was heated or changed in the state. So an irreversible change, an example of it is mixing, heating, burning, and rusting. Now, in most cases, a new material is formed. So the reason why we can't make it go back is because the metal turns into something else, and the heating, you burn something, you mix something that they react. Okay, so basically, frying an egg, it's a irreversible change, because you cannot turn the egg back to its in its shelf, and it won't go back to the same thing that it was. Okay, so once you heat the egg, all the proteins start to react, and they will create something else, and the form of the proteins in the egg changes, so a new material or a new form of the egg appears. Okay, now how about sweet potatoes, or just potatoes in general? You slice the potatoes and you fry them, or you put them in the oven because of the heating, right? So the potato will bake, or or boil, or get fried, but then it can't go back to the same thing. Now if you smash it, then it definitely cannot go back to the same states that it was, right? Okay, now mixing. Okay, you wonder how mixing can actually be an irreversible change, because sometimes you mix stuff like salt and water, sand and water we had before. All of these can obviously you can evaporate the water, and the salt remains in the container, or the sand you can basically filter it out. But this is another type of mixing. This is different. So we have some materials, so some stuff like baking soda, okay, and vinegar. Basically, you basically if you mix these two, the particles will react together, so they will create something that is new. Okay, so this is how mixing can actually be an irreversible change. Now, this is an activity, and the purpose of this activity is that you understand how you answer scientific investigation question in the exam. Now, for each activity, as we have learned, okay, this is an instructional text. From English, we have some points: 1, 2, 3, 4, 5, 6. 6 points, 6 steps, and the activity is such as follows. Okay, so we wear safety glasses. Obviously, you place because we're dealing with chemicals. That's why we obviously need to wear safety glasses, and you place 50 grams of bicarbonate of soda, that's just this soda, in a balloon, and use a cardboard one, right? So a cardboard cone, right? So a cone is basically to help us pour the bicarbonate of soda inside the balloon, right? And we place 50 milliliters of vinegar in a bottle. Okay, so that's 50 grams of bicarbonate soda, 50 liters of vinegar. We carefully stretch the neck of the balloon over the bottle without getting any of the bicarbonate of soda spilled into the bottle. Okay, so you lift up the balloon to tip the powder into the vinegar, and you repeat the double the bicarbonate of soda and vinegar. Okay. And the result of this activity, now you can try it just by mixing soda and vinegar, but you need to be very careful. And you also obviously bicarbonate soda of soda is a type of soda, so it's not that easy to get. But if you were to try it, you need to try it on a sink in your kitchen, and you need to wear gloves, and you need to wear all the the clothing that that you won't be worried that it would be damaged. So the reason why there's these two, specifically these two things, vinegar and bicarbonate of soda, are, as an example here, is because when they mix, they will create something. Now, for our science fair, which we didn't do because of the quarantine and everything, the science fair, we were mixing some sort of dish soap with some other material. We were creating this elephant toothpaste. Now that's also an irreversible change. So it's something like that. That's something that cannot go back to the same state that it was, right? So we have a powder called plaster of Paris, okay, and water. Obviously, any solid powder, solution, anything that mixed together creates something else is an irreversible change. Okay, so it just describe the changes that made to the bread when it turns into a toast, right? So if you leave it enough in that machine or leave it enough in the oven, you basically burn the toast, and the toast cannot be eaten anymore, right? Right. What happens when you burn a candle? Okay, what part of the candle burns? Okay, blow out the candle and hold the flame back to the wick without touching it. What happens? What does it tell you about the burning, right? So obviously the material that the candle is made of, the candle itself, it's wax, and it's made of beeswax and other type of wax we have, right? So unless you have some of it, you can always recycle it and put it back together and put it on the heat, and it will change the shape again. But then afterwards, when everything is burnt out on the candle and the small string inside the candle is burnt out, you cannot get back the same string back, because the heat or the fire will actually burn it out. Okay, same thing with matches. What happens when it burns, right? So imagine like the color changes, everything, the material shape and the material weight, it all changes, right? Right. So we also have metal. Now, the reason why metal gets rusted is because we have oxygen in the air, right? So we have oxygen in the air, and little particle oxygen, it's a gas. So the little particle of oxygens, they always run around. So they bump into these surfaces of the metal, okay? Once they bump into them, the oxygen in the air reacts with the metal. And this reaction between them creates this reddish, brownish colored material outside of the metal that looks very nasty, okay? And this basically is rusting. So it's basically oxidation. It's oxidizing the outside of the metals. We usually cover these metals in basically, sometimes covers, plastic, waxes, these type of anything that covers these metals are used to prevent it from rusting.